Projects are an important part of this course because it makes you combine all the concepts from statistics that we're going to learn in a way that integrates them and helps you understand how we actually do analyses. To help you understand what projects look like, I've given you this review of past projects activity, where you will look at 3 different projects and pick out some of the big details. This demonstration is with a 4th project, so it's not one of the 3 that you will be looking at, but it should give you some guidelines for how to complete the activity. So notice in this, we want project 4. And so what we're going to do is go to my website, which is shown here at pierce.ctc.edu. And if you click on the Math 146 page and scroll down, you will see project resources. And scroll farther down, you see sample projects. And we want the one that says Sheppard-Engel. And so we'll click on that and we'll open it. And we're not going to print this out because there's no need for it to be printed, but we will read through it, or you should read through it. So you get an idea of the different sections of the project, such as an abstract. Notice that abstracts are short and ultimately tell you what the results were. Then there's an introduction. Sheppard studied physics, and so this is more scientific than most projects end up being. Methods, how it was done, and then the analysis, and finally conclusion, and then he added an appendix as well. So after you read through it, most of what you need to answer the questions is found in the analysis section. And if we look at the questions, the first one says, which statistic is used? Means. Means are used when you have a lot of numbers that you add up and divide. So you might know the term is average. Proportions are used. Think of proportions similar to percents. If you multiply a proportion by 100, you get a percent. And correlations occur when there's 2 different variables and you want to see the relationship between them. So when we look at the analysis, one of the things we notice is the word average. And that is a big clue that we're talking either average or mean. Notice here also is the word mean. So it's fairly straightforward when you have mean or average. It's written in there. So to answer this question, we would write in mean. Which graph is used? So was it a pie chart, a histogram, or a scatter plot? Well, here's an example of the different types of graphs. This is what a pie chart looks like. It has various slices that tell how many and what percent of the values fall within each category. In this case, it was a change in unemployment rate from the prior year. So 22 times it went up and 35 times the unemployment rate went down. This is a pie chart. A histogram is a bar graph. The bars will touch each other. The y-axis is the frequency or the number of observations. And in this case, this is unemployment rate. So what the unemployment rate has been, I think this was between 1947 and 2006. And this is a scatter plot. This compares the inflation-adjusted cost of a barrel of oil with the U.S. unemployment rate 2 years later. And so we have quantitative or numeric values on the x-axis, numeric values on the y-axis, and each point represents the cost of oil and the unemployment rate 2 years later. And so you can see if there's a relationship between these two variables. The closer they are to a straight line, the stronger the relationship. Now, that's a little more information than you need right now. So when we look at the graph that Shepherd has, we see it's a bar graph. It's certainly not a pie or a scatter plot. So, and the bars are touching. And so this tells us that it's a histogram. The lack of bars touching here does not change the fact it's a histogram. It's just there was no data in those ranges. So this is a histogram. So we'll type that here. Now also, although this isn't part of the question, this is what's called a box plot. And so it's just a different way to represent the data and draw a comparison. Now ultimately, we test our hypothesis, and somewhere in the analysis section you should find a sentence that corresponds to the sentence that is written in the activity. And so in this case, it says average coefficient of static friction found using the inclined plane method. Now we have this is not. You will see these on this activity. You will see this on different tests. You've got to remember to circle which one is appropriate. So in this case, when we read the sentence, the average coefficient of static friction found using the inclined plane method was found to be significantly different. So that means it is significant. So we're going to circle the word is. And then it asks us for some information. And while these are important, it's a little too early to explain what they mean. But we'll just take it right off of Shepherd's information. So t is equal to minus 4.23. Don't forget minus signs when they appear. The p-value is 0.0001. And df, which stands for degrees of freedom, is 39.4 degrees of freedom. And that is all you have to do to complete this activity.